Section 1-6 is entitled Solving Compound and Absolute Value Inequalities. Now, a compound inequality is two inequalities that are joined by the word and or the word or. An and inequality is the intersection of two inequalities. In other words, both of the inequalities must be true. So, for example, x is greater than or equal to -3 and x is less than 4. Both of those must be true. So I've graphed x is greater than or equal to -3 here in pink, and x is less than 4 here in blue. And in other words, what numbers meet both of those criteria? What numbers are greater than or equal to -3 and less than 4? And that would be the numbers in between here where the two inequalities overlap, where you have the pink line and the blue line. And actually the better way to write it is like this. So anything that's greater than or equal to -3, but also less than 4. We can write this inequality this way with the word and in between it, or I actually prefer to write it this way. And actually writing the inequality this way looks a lot like the graph. -3 is less than or equal to x, which is less than 4. And actually that looks a lot like what the graph looks like right here. An or inequality is the union of two inequalities. Either one or the other is true. So either inequality can be true. So x is either less than or equal to -3 or x is greater than 4. So anytime this would apply to any number where x is less than or equal to -3 or x is greater than 4. We're going to keep both parts of that. And this can only be written as x is less than or equal to -3 or x is greater than 4. There's no shortcut way to write it without the word or. So let's take a look at a couple examples here. Solve each inequality and then graph on a number line. This is going to be an and inequality because it doesn't have any words in it. I could also break this down and write it as an and, but it's actually easier to solve this way. My goal is to get x all by itself right here in the middle of the inequality. So I'm just going to kind of like solve that for x. So the first thing I want to do is add 2. And I need to add 2 to all three parts of this. So that's going to give me 12 is less than or equal to 3x, which is less than 21. And now divide all three parts by 3, because remember I'm trying to get an x all by itself in the middle. So 4 is less than or equal to x, which is less than 7. And that's my solution. Now to graph that on a number line, I'm going to put my two numbers of interest on there, 4 and 7. Don't worry about any other numbers. And x is going to be in this space between 4 and 7. And since this is a less than or equal to, I'm going to have a solid dot here over the 4. And since this is a less than, I'll have an open circle over the 7 and connect them, and it looks kind of like a barbell. And that's what my graph looks like. Here's an or inequality. And I know it's an or inequality because it has the word or in it, and I can't write it as just one expression. So x minus 6 is greater than -11, or 2x plus 4 is less than -15. I just solve each part separately. So adding 6 to both sides. X is greater than -5, or subtracting 4 on both sides. 2x is less than -19, and dividing both sides by 2. X is less than -19 over 2. And writing my final answer, x is greater than -5, or x is less than, and actually to graph this, it would probably be easier to turn that into a mixed number. And that's actually -9.5. Although you're welcome to leave it as an improper fraction. I just find that when I'm graphing, which is the next step here, it's easier to have a mixed number. So here's my number line. -9.5 goes over here. -5 goes over here. X is greater than negative 5, or x is less than negative 9.5. And that's what your graph will look like. Now, combining absolute value and inequalities, we have absolute value inequalities. They have both an inequality sign, a less than or a greater than, or it could be a less than or equal to, or a greater than or equal to, and absolute value bars. So in order to solve an absolute value inequality, we need to turn it into a compound inequality. And here's a real cute way to remember which you turn it into. If it's a less than or a less than or equal to, I want you to think of that as a less than, and it turns into an and inequality. If it's a greater than or a greater than or equal to, it's greater, and it's going to turn into an or. Okay? Here's kind of the idea behind that, but that's a little confusing. I'll show you how it's going to work out here. So solve each inequality and graph on a number line. So this is a greater than, so it's a greater. So I have to write this as an or inequality. My first step is to take it just as it's written without the bars. So 3x plus 5 is greater than 14, or 3x plus 5, and here's the tricky part, is going to be less than a negative 14. Now think about the way this is going to look when it's graphed. Something is going to be greater than a positive number, so going off in the right direction, or something that's going to be graphed is going to be less than a negative number, going off in the negative direction. And most of our ors look like that. There's a part going off to the right in the positive direction and a part going off to the left in the negative direction. So it's greater than a positive or less than a negative number. Now let's solve each one. Subtracting 5. 3x is greater than 9. Or x is greater than 3. Subtracting 5. 3x is less than negative 19. Or x is less than negative 19 over 3. To write my final answer, x is greater than 3, or x is less than negative 19 over 3. And it doesn't matter which part you put first. Most people will put the negative part first. But definitely when we go to graph, I do need my negative 19/3 over here. And I need my positive 3 over here. And it's going to be greater than 3 or less than negative 19/3. And that's what your graph will look like. Number 2, the absolute value of 4x minus 3 is less than or equal to 7. This is a less than. So this is going to turn into an and inequality. Okay? And remember, an and inequality has something in the middle. We're looking for the overlap. So the best way to write this is to copy it without the bars. Okay? And I'm not going to use the word and. I'm going to take this less than or equal to sign and put another one in front. And then instead of a positive 7, over here I'm going to have a negative 7. So the stuff that I'm graphing is going to be between a negative number and a positive number. And now I can just solve this. Add 3 to all parts. It's going to give me negative 4 is less than or equal to 4x, which is less than or equal to 10. Dividing everything by 4. It's going to give me negative 1 is less than or equal to x, which is less than or equal to 10/4 is the same as 5 over 2, or 2.5. And there's my answer. And to graph, oops, let's do a better line here. I'll have negative 1. 5/2 is actually 2.5. And my x is going to be between those two numbers. X can be any value that is both greater than negative 1 and less than 2.5. And that's what my graph looks like.